Good afternoon and welcome to today's machine design webinar. Our topic today is servo motors and shaft couplings combined to boost productivity, sponsored by NBK America and SANYO DENKI America. I'm Bob Vavra with Endeavor's Design and Engineering Group. Let's talk about how you can participate in today's presentation. If you have any technical difficulties during our session, simply type your issue into the Ask a Question box and a member of our team will assist you. You can also click on the question mark help button in the upper right corner of your screen. We also welcome your questions during our event today, and we'll get to as many of those as we can during the Q&A session that follows the main presentation, so feel free to send in your questions at any time. To do so, simply type your questions into the Ask a Question box and click on the Send button. If you'd like a copy of this presentation, please click on the Event Resources tab on the side of your screen to download the presentation. Please be aware that today's session is being recorded and will be available on the Machine Design website within the next week. You'll be notified by email when the archive is available. So let's meet our presenters for today. Mitch Nakamura is the Sales Engineer Specialist for NBK America, where he's worked since 2018. He serves as the Regional Sales Manager for Canada and Midwest America. He's primarily based in King of Prussia, Pennsylvania, outside Philadelphia. And prior to NBK America, Mitch worked for NBK Japan, where he served as an overseas sales representative for the Asia-Pacific regions. And Eric Flores is an applications engineer at SANYO DENKI America out of Torrance, California. He's in charge of supporting the Midwest and East Coast sales managers. Before working for SANYO DENKI, he was a test engineer for UPS Systems in Gardena, California. So Mitch and Eric, welcome. And Mitch, why don't you get us started this afternoon?
Thank you. My name is Mitch Nakamura. I am a sales engineering specialist with NBK America. I'll be discussing the benefits of Nbkxg series coupling and also the reason why just changing a coupling can help maximize the servo motor performance today.
Hello, my name is Eric Flores, and I am an application engineer for SANYO DENKI America. And today I'll be discussing our R1 low inertia motor as well as our new G series product line.
All right, so first off, which of us is going to introduce our company? NBK America. It is located in the suburb area of Philadelphia, Pennsylvania. We distribute made in Japan NBK brand products in North America. We do engineering consultation, customer service, and we do warehouse. Here is NBK Group. Our headquarters is located in Gifu, the central Japan. The right picture shows our headquarters called Seki Garden Factory. We develop, manufacture, sell NBK brand products. We have been doing these since 1560. Yearly turnover, $115 million as of 2021. The total number of employees in the NBK Group is 421. We are ISO 9W01, ISO 14W01, ISO 5W01 certified. Here is NBK Global Network. Besides NBK America in Pennsylvania and the Japanese headquarters, Seki Garden Factory, we have a foundry in Japan and they produce cast iron products. In China, we have a manufacturing plant and sales offices. NBK China locally support the China market. For the rest of the country, we supply our products through our distribution channels. NBK Group, we can support your business globally.
SANYO DENKI Corporate is located in Tokyo, Japan, and was founded in August 1927. As a whole, SANYO DENKI Group has roughly 3,631 employees as of March 31st, 2022. Part of our global network includes sales office in Europe, Southeast Asia, East Asia, and North America, where SANYO DENKI America is located in Torrance, California, with sales offices in Silicon Valley and Chicago, and a repair center in Detroit.
All right, thank you, Eric. So why are we're together today? NBK has the latest coupling model Xg series. The concept is just changing a coupling can help maximize the servo motor performance. From SANYO DENKI, They have the latest optimized agility of low inertia servo motor R1 series that shortens takt time. Collaborating by SANYO DENKI and NBK, our synergy can bring the most comprehensive and optimal takt time for you. Let's see what we can do throughout today's presentation. From next slide, I'd like to reveal the secret of Nbkxg couplings. This graph illustrates the servo motor history. Before 2002, full metal type couplings such as slit, disc, and bellows were the mainstream in the market because the higher rigid coupling is always better for the positioning accuracy. After 2002, the motor performance was dramatically evolved from 1000 Hz to 4000 Hz. What happened was severe vibration enhancing problem. In order to prevent from the vibration issues, the engineers needed to suppress motor function, which is lowering gain, and they struggled not to be able to maximize the servo motor function, meaning there was limitation of shortening takt time. As we are a coupling specialist, we approached a new way of dampening technologies, which suppress vibration and noises. It enables to increase the servo motor gain and more aggressively and made shortening takt time possible. Therefore, XG couplings were released to cope along with the latest servo motor. This is the structure of XG couplings. Two aluminum pods and vibration absorption materials are nicely integrated as one single structure. It is zero backlash for a perfect fit for the motion control application. Let's see the differences between disc and XG couplings when stopping the motion. The first graph shows the coupling vibration. As you can see, disc-type coupling keeps vibrating right after the stopping the motion. And how about the boat plot, which shows noise occurrences? As you can see, it picks up hunting noises. In the meantime, XG series, it absorbs the vibration right away. Also, noise is suppressed. Let me address the terminology gain. Gain is a parameter of servo motor, and you can just think that it's the motor come out level. When you increase a gain level, the motor commands are more powerful and more demanding for the torque transmission. Therefore, it shortens the stabilization time, meaning positioning speed is more increased and it leads to improve the industrial productivity. Let's compare gain level 27 versus 35. The orange line indicates the motor commands, and red line, it indicates the coupling actual response to the motor, which is the actual operation. Blue line, it is stabilization time, and it is the gap between motor command and coupling actual operation. At gain 35, it increased gain level and the stabilization time gets very short. I would like to play a video showing metal coupling versus XG coupling in the next slide.
Compared with disc-type couplings, the XG series has a very high damping capability and therefore absorbs vibration. The hunting phenomenon that occurs in disc-type couplings is suppressed by the XG series. As increased servo motor gain does not cause hunting, the XG series allows servo motors to operate at a higher gain level. The result is a shorter stabilization time. A disc-type coupling stabilization time is 15 milliseconds. but the XG series is only 3 milliseconds. The approximately 80% reduction in stabilization time results in high-speed positioning.
Okay, thank you for watching. So as a result, just changing a coupling helps increase the gain level and it shortens the stabilization time by 80%. I'd like to introduce some of the adequate applications for XG couplings. Surface mount machines as in wire bonder, chip mounter, and the back-end semiconductor process, and CNC vision measuring machines to improve the inspection time. Genetic analysis device for the countermeasure of noise and vibration, and press brake for suppressing noise and vibration. The flex image inspection machines, and of course, linear actuator. These are only one of a few application examples. From next slide, Eric is going to explain the low inertia servo motor R1 series. Eric, can you start to explain the secret of R1 servo motor?
Yes, of course. I will discuss the benefits of our low inertia motors, part of our SandMotion R AC servo systems product line. Low inertia motors are beneficial because the motor must be able to run the rotor inertia as well as the external load inertia. That is why lower rotor inertia is more beneficial. The motor has smaller rotor inertia, which means it needs less torque to operate. So I will discuss the rotor inertia and output armature torque. The equation on the left shows how to calculate the moment of inertia around the center axis of the cylinder density. I is the length and D is the outer diameter. The equation on the right is for armature torque. Kw is finding a factor and its constant. AC is specific electric loading. The specific electric loading is defined as the number of armature conductors per meter of armature periphery at the air gap Bg. Is the specific magnetic loading. The specific magnetic loading is defined as the total flux per unit area over the surface of the armature periphery. D is armature in internal diameter, and I is armature core thickness. So armature inner diameter D and rotor outer diameter small d are separated by a certain air gap length. The moment of inertia and torque are in correlative relationship through the stator's internal diameter D. For example, in case where our outer diameter is reduced by half, inertia is reduced and torque as well. So there's a couple ways to adjust armature torque. One by adjusting the motor length to increase the torque. However, customers do not want longer motors. The second option would be to increase torque generated by the motor armature in different ways, like improving magnetic loading and or electric loading. So improving magnetic loading, the field flux source produced by the magnet force of the permanent magnet must be strengthened. So, however, this is difficult at this time because since 2006, the growth of rare earth magnets has plateaued. As the graph shows, the growth between the mid-1980s to the mid-2000s is much larger than that of 2006 and onward. So since magnetic loading is difficult to achieve, we are able to improve torque at higher speeds by increasing specific electric loading by improving the fill factor of the armature winding. In this graph, you can see the vertical axis is torque, horizontal axis is speed. The yellow line displays our R1 product line being able to produce higher torque at various speeds compared that to our conventional product. So in this graph, it shows the comparison of the motor inertia. Y-axis is rotor inertia and X-axis is motor power. Yellow is low inertia. Gray is medium inertia motor. So comparing the same size motor for 100 watt, the low inertia has 0.0242 times 10 to the negative 4 kilograms per meter squared, but the medium inertia has 0.0627. Lower inertia motor has 60% smaller inertia than that of the medium inertia. For our 5 kilowatt motor, almost half. So our low inertia motor can have anywhere between 50 to 70% less inertia compared to that of our medium inertia motor. So this graph is showing the comparison of power rate. Power rate is the rate of increase in output that a motor can produce, which is the square of the rated torque divided by its own inertia. If the power rate is higher, then the motor can output torque at a faster rate. So in this graph, the vertical axis is power rate, horizontal axis is motor power, blue is low inertia, and gray is medium inertia motor. At 100 watt, again, the medium inertia motor has 16 kilowatts per second, but low inertia motor has 42. So 2.6 times larger than medium inertia motor. For 5 kilowatts, 2.1 times larger than medium inertia motor. So our low inertia motor has 2 to 3 times larger power rate than that of the medium inertia motor. So these graphs are showing the effect of different load inertia on the frequency response of the speed loop. JL is external load inertia, JM is rotor inertia, GSP is proportional gain, where JL is 100%, the external load inertia is equal to the motor inertia. So gray indicates zero gain, whiter levels indicate positive gain, and darker levels indicate negative gain. Where the inertia ratio is 100%, the servo response is very balanced. So comparing to the rotor inertia at 100%, the middle graph, the darker color for the rotor inertia is 400%, is larger than 100%. For 1200%, it's much larger than 100%. That means the gain goes to negative and the delay goes to the command increases. On the other hand, 50% and 0%, the gray color area is turning to whiter. That means that gain goes to positive, and that makes the motor response more aggressive, and the oscillation happens easily. Either positive gain increase and negative gain increase make the control unstable, but especially for positive gain increase. It is hard to reduce the effect by tuning several parameters. So using low inertia motor, we can avoid the high gain level. For example, as in the earlier slide, the rotor inertia of a 100 watt low inertia motor is 60% smaller than that of the medium inertia motor. If the inertia ratio is 50% when using a medium inertia motor, we can change it to 125% by using a low inertia motor. 125% is closer to 100%, which means that the servo response is more stable than 50%. So using a low inertia motor, you can get higher inertia ratio and avoid oscillation to increase. To know how large the load inertia is in major applications, we did an analysis of the actual load inertia values that we calculated in motor sizing. This graph is showing the relations of load inertia and selected motor power size. So the dotted line is 20 times that of the medium inertia motor, and the line below that is 20 times of low inertia motor. Applications in the light green, our robots and machine tools have large inertia for inertia motor, so the medium inertia is more stable. I meant blue, not green. Applications in the pink line or red, semiconductor and conveyors do not have large inertia. Applications in the green, electronic components and manufacturing and assembly machines have very small inertia. So our low inertia motors fit well in these two areas, which would be the red and the green area. So as discussed earlier, the low inertia motor has a higher power rate, and the motor can accelerate quicker than that of the medium inertia. We can check the power rate in the spec sheet. However, to clearly understand acceleration under load, we conducted an acceleration simulation. In the simulation, the motor in a static state starts rotational motion triggered by the peak torque. Then the speed increases in line with the torque versus speed characteristics curve until maximum speed is reached. Here we define the time taken to reach command speed as response time and change the load inertia to calculate how response time would change. The graph is showing the results of the simulation. Vertical axis is response time in seconds, and horizontal is load inertia. The yellow line is low inertia motor. As you can see, the low inertia motor is 20% faster than that of the medium inertia motor. After simulation, we performed a test where we used the 100-watt motor from our medium inertia and low inertia product line and attached the same coupling with the same actuator and repeated a very short positioning movement 20 times. The command speed was about 3,300 RPM, and each movement was about 7.5 millimeters long. We took data using our built-in scope on our amplifiers. The positioning results of each step was as follows. The left side is low inertia motor, the right side is medium inertia motor. Green line is torque, and the red line is shows velocity. Low inertia was 37.5 milliseconds. Medium inertia was 43.8 milliseconds. Low inertia is 6.3 milliseconds faster than that of the medium inertia. Also, comparing the acceleration torque to reach peak speed, the low inertia generated 20% less torque than that of the medium inertia motor under these conditions. So the following video will show you the difference in positioning time between our R1 and R2 motor lines. As you were able to see, our R1 motor has much faster settling time, which can benefit applications that need higher production output. So this chart is showing which motor would be adequate for which axis where the application has an XYZ. For general applications, we will always recommend our R2 product line for XYZ. However, where high-speed motion is needed, we would recommend our R1 in the X and Y axis. Where the application has low load inertia and where the speed of XYZ axis would affect the cycle time of the equipment.
All right, thank you, Eric. As Eric explained, you understood the benefits of SANYO DENKI R1 servo motor, and it did show the improvement of shortening tact time. Remember, I previously explained changing a coupling to XG series can shorten the stabilization time by 80%. Let's see how much R1 servo motor and XG coupling can bring the outcome. All right, now R1 servo motor and metal type coupling bellows, the maximum gain level was at 23. However, R1 servo motor was using XG coupling, a gain level was increased up to 40. Therefore, the stabilization time was reduced by 97%. And this is the outcome of the synergy with Nbkxg coupling and SANYO DENKI R1 servo motor. From next slide, NBK and SANYO DENKI are going to introduce our further solutions and additional services to your needs. NBK, we have a variety of couplings such as vibration absorption, bellows, disc, Eldon, jaw, rigid, and so on. And I am confident that we have the richest coupling lineup in the world, and NBK can suggest the most suitable couplings based on your applications and needs. We have modification services with bore size and keyways. Also, changing the clamping bolts to stainless steel is available. You can request based on your needs.
So SANYO DENKI, our servo systems product line, it's named SANMotion, but we also have not only just servo systems, AC and DC, but we have our stepping systems as well. We have closed loop stepping systems, 2-phase, 3-phase, and 5-phase stepping product lines. We do have linear servo motors as well, and we have motion controllers. So our SANMotion G is our new product line, which will include new and improved servo amplifiers and servo motors. Our servo amplifiers will include an EtherCAT and analog pulse interface with improved frequency response, positioning settling time, and a new variety of diagnostic tools. Our servo motor will be about 22% shorter, higher resolution encoder, increased max speed, and newly developed holding brake. Our new G-Series G-Servo motors will have stable positioning accuracy with standard encoder of 23-bit and up to 27-bit option for high resolution control. Frequency response improvement has been made to our new amplifiers compared to that of our conventional product, going from 2.2 kilohertz to 3.5 kilohertz, which is about 1.66 times improvement. Our G series has shortened positioning time. As you can see on the graph, positioning settling time has shortened to 1/3 of the original time. Output voltage has improved about 7% by the way of our new PWM control. Maximum speed has increased to that of our previous product lines from 6,000 RPMs to 6,500 RPMs. So our new product line is able to produce more torque at higher speeds. The lineup includes an analog pulse and EtherCAT interface drive ranging from 10 amps to 50 amps, available in 100 VAC or 200 VAC voltage. And the motor lineup will include from about 30 watts to 1.2 kilowatts for our G series product line. And R1 low inertia motor has a lineup ranging from 50 watts to 1.5 kilowatts. Bob, we are ready for our live Q&A.
Great, thank you. We've got some questions submitted, and we'll be getting to those in just a moment here. If you'd like to submit a question, type it into the Ask a Question box and hit the Send button. Also, please take a moment to complete the feedback form. It'll be located on the bottom of your screen at the end of the webinar. Number of things we wanted to go over. Let's start with this. Does the coupling's torsional stiffness impact the positioning accuracy and repeatability of the linear actuators?
Okay, so I would like to address with this question. Give me 1 second. All right, so the first question, does the coupling torsion stiffness impact the positioning? The answer is the coupling torsion stiffness does not significantly make an impact on positioning accuracy. We had positioning repeatability testing on 3 coupling models. The major locations were set at 20 millimeters, 170 millimeters, 350 millimeters from the start point on the actuator. Loaded object, it was 3 kilograms. Driving was repeated 7 times under the same conditions. Here are 3 different coupling models. Number 1 is the XGT vibration absorption type. Statistic torsional stiffness is 170. Number 2, XPW disc type, and it's 850. MJT gel type is 55. Here is our testing result. The bottom line shows the average value of each coupling's overshootings from the measuring points. XG couplings 0.0015, disc type 0.0012. Lastly, gel type is 0.0012. As you can see, the value of disc type has the most accurate positioning because the data shows close to 0 point. However, the XG coupling is 0.0015. The difference was only submicron level. We can say the statistic torsional stiffness, even XG coupling is quite different from disc type coupling. Coupling's torsional stiffness does not significantly impact the positioning accuracy. Speaking about the torsional stiffness, I would like to give you some additional information. You actually need to think of the whole unit rather an individual component torsional stiffness level. The whole unit is composed by a motor, a coupling, bearings, a bow screw, and such. Let's see the torsional stiffness of bellows type 7,000 and XG couplings 590. When calculating in the formula, each coupling torsional stiffness turns out small as in whole unit. From this point of view, coupling torsional stiffness does not significantly impact the whole unit, nor positioning accuracy.
Okay. Next question that's come in is are the XG series coupling life shorter than the other coupling models?
Could you say that again, please?
Sure. Are the XG series coupling life shorter than other coupling models?
Sure. So it's another coupling. It's about durability then. Okay. So about the coupling life, XG coupling life, the answer is XG coupling attained 100 million drives and tests. And we had a testing that XG couplings, which inserted in the testing equipment under the condition of max torque and max misalignments, it ran back and forth to see the durability. If there was any damage on the coupling turns more and angle would exceed. As a result, there was no coupling damage to be confirmed, and before and after 100 million driving, there was not much change in the coupling driving angle. Any other questions?
Yes. What's the difference in motor length between the medium inertia motor and the low inertia motors?
So I actually have a slide here for you, Bob. So our low inertia motor has 50 to 70% less inertia compared to that of our medium inertia motor. However, it is negative 10 to 30% longer than our medium inertia motor.
Okay, very good. Next question is, what kind of amplifier interface options do you have for the low inertia motors? And can I use low inertia motors as a standalone?
So the type of interfaces we have are we have analog pulse, EtherCAT, Indexer I/O, and Indexer Modbus RTU, available from 50 watts to 21 kilowatts in 200 VAC and 50 watts to 200 watt 100 VAC. And yes, technically you can use it in a standalone, but if you're gonna use if it's in a motion control application, I think Indexer I/O would probably be the easiest with just simple inputs and outputs controlling the unit.
One other question on low inertia motors. Do you have any value add options when purchasing low inertia motors?
Yes, Bob, we do. So as SANYO DENKI can offer a whole solution for a package, starting with our NBK vibration absorption coupling, our SANYO DENKI low inertia motor, our high precision actuator, connector assembly and extension cables, and of course our amplifiers and motion controllers. But we also have tech support, which can include parameter setting and/or programming for your controller and your system.
Good. We have time for one other question here. This is from one of our audience members. Can this type of coupling be used on a stepper motor that has an encoder feedback, smart motor with a 4,000 PPR encoder, and micro stepping?
Okay, I can answer. Thank you, Bob. I have a slide for that. So, stepping motor with XG coupling, yes, it is effective, and it's a great solution for unevenness of cutting torque in the slow motion. And also, if you're concerned because your application has heavy loading, machine tools processing for hard work metal pieces, I would recommend our XG-HW series for your information. This is a new addition to XG series family couplings, and XG-HW coupling main body is full metal coupling, disc type coupling, and then a vibration absorption material is attached. So XG-HW body rigidity is higher than XG couplings, and vibration function is less compared to XG couplings. However, once again, it is adequate for high loading applications, machine tools for hard work pieces such as ceramics and glass.
A couple other questions have come in here. Eric, this is for you. Does SANYO DENKI make a smart stepper or servo motor?
Smart stepper or servo motor, not like a standalone unit. We do have our amplifiers and our controller that can be kind of used, and you could kind of say in a smart network. Our controller has a HMI visualization built in. So if you're talking about a full smart motion control system, I would suggest using our controller with our EtherCAT drive and then our R1 motor as well.
Very good. And along the same lines, can an external linear encoder be added to the SANYO DENKI motor system?
Yes. So we have our servo amplifiers. You could actually attach a linear motor, and then you could see outputs of that linear motor on our amplifier. It is a special type of amplifier because our standard comes with, I think, just one encoder, which would be the servo motor. But we do have that option to attach a linear encoder onto our drives as well.
Very good. That appears to be all the questions we have for the moment, but if we didn't get to your question during this session, we will be circling back with you offline. And my thanks today for Mitch and Eric on a great presentation. Thanks to all of you for joining us, and on behalf of Machine Design, I'd like to thank NBK America and SANYO DENKI America for sponsoring today's event. Of course, thanks to all of you for joining us. Have a great rest of your day and stay safe out there.